Hi, Roselle. Great detective work on that assignment. That's really helpful. The one thing we keep running into is that he switched the axes on the question that he gave you, and it makes it a lot more difficult to follow any of this stuff because you actually end up with dx dy rather than dy dx for your slopes and things because the axes are reversed. So what I'm going to suggest to begin with, because this is such a difficult problem anyway, right now what we have is we have the -1 here, as that's the position of the drone, and it's following the train along the x-axis like that. And there's nothing in any of the literature that I can find that shows you how to do it from that standpoint. Everything gets reversed, your slopes are upside down, and it just makes it really, really difficult as if it's not already. So let's do this. Let's just say that this is equivalent to this problem, where if we have the train traveling from south to north, and I'm sorry, no, skip for just a minute. Oh, I don't think it's going to let me erase now because I did it in the wrong order. No, okay, so scratch that. All right, just ignore that for a minute. So if we do this, and we have, okay, so here now we're going to put the drone on the x-axis, and it's 1 away from the origin, and it's traveling in this direction towards the train, which is going this way. If you take that whole thing and turn it 90 degrees, we've got exactly the same situation. But what that does for us is it puts it on the opposite axes, which all of the examples in his solution are working from. And so I don't know if he meant to write it as the way he did, because it's backwards based on everything else that I've been able to find. But if we do this, then it's going to give us the exact same distance, and that's the question, is find the distance along the tracks before they catch up. And that's going to give us the exact same answer. It'll just give it to us going in the north-south direction instead of the east and west direction. So what we want to do, I'm going to do this in 2 parts. I can't even promise that I can give you the second part because that's something that he's done on his solution using Maple, and it gets really, really crazy. So let's get at least to the part where we can show that that's the equation. So the first thing we need to do is pick a point somewhere along this curve, and that point is going to be some point x and y, okay? And we know that this point right here is over 1 and up 0 on the x-axis, and we don't know the point where they're going to meet. So the first thing we can do then is we can find the slope of the tangent line from any point where the train is traveling through this point xy on the curve so that it's tangent to the curve like that. And we can find the slope by calling this point here 0 u, we'll just pick u as a variable for the y value as far up on the axis as it is, and we're going to do y2 minus y1, so we'll do u minus y over x2, which is 0, minus x1, which is just x. So if we simplify that a little bit, we have u minus y over negative x, and instead of having the negative, we'll divide everything here by a negative, or multiply everything by a negative, and end up with y minus u over x. So then he goes on to solve the equation. This is dy dx, right? And so, so the slope is dy dx, that's m. It's equal now to y minus u over x. And if we rearrange that equation, we can bring the x and multiply it by this. So we'll have x times dy dx equals y minus u, like that. And we need to solve for u. So I can bring the y over to that side. I have x times dy dx minus y equals minus u. And if I multiply everything by a negative here, I'll get negative x dy dx plus y equals u, or u equals y plus y minus y minus x dy dx. Okay, so that's the first part. All right, it's not the whole first part, and already we're at 5 minutes, so let's do the next part. I might have to do this video in two parts, okay? So the next part that we need to consider is that this, sorry, I'm trying to move my screen up and it doesn't want to cooperate. There we go. Why didn't that guy move up? Okay, so the next thing that we have to consider is that the point xy is along the arc length of that curved line of that pursuit curve, okay? And so that's the distance that the drone has traveled, okay? So distance traveled by the drone is always going to be the arc length of that curve. So in this assignment, the one that you sent me, he is saying that if you go to your book, you can find this equation for the arc length, and that you guys haven't actually covered that yet in the course, or they hadn't covered it in the course where he gave that assignment. So I'm assuming that you can pull that equation in, which is one of the problems I was having last night, was like the equation wasn't provided for the arc length, and I thought you had to derive it, and it's such a big job to derive that equation and understand where it comes from. But if we have it, then we can use it, okay? So the other thing that we know is that the velocity of the drone and the train were given to us. And so we can say that the velocity of the drone is 200 kilometers an hour. The velocity of the train is 100 kilometers per hour. So the velocity of the drone, we called this u, didn't we? Because that's the point along the y-axis at any time t that the train is traveling. So if we say that the velocity of the drone is I'm sorry, that was the train. If we say the velocity of the train at any time is u, then the velocity of the drone is 2 times that, because it's 200 instead of 100. And so we know then that 2u has to equal 2 times that equation that we found up at the top. Okay, and the very last thing that we're going to do now is, because that's the velocity of the drone, that's the path of the drone along that curve, we can now put that equal to the arc length formula. And we can say that 2 times y minus x dy dx equals the integral of x to 1 of this guy. Okay, so I'm going to stop there, because the next part is a little bit long too. We need to take the derivative of both sides. So I'm going to do another video to show you how to do that, and how to arrive at the equation that he gave you in your assignment. And then it gets really tricky trying to actually calculate the distance.